I guess we can just use the front. Okay, so let's. Okay, so what was the attendance function? Can you someone tell me nice and loud and clear? Nope. Okay. Okay, and so let me write these two things up here. And I want you to tell me what's the difference between these two line statements? What's the difference between, besides the fact that one has a capital T in it and the other has a capital X in it? What does that mean? What's the implication of that using a different letter, capital T versus X? Here. Like the x-axis. Absolutely true. What she said is absolutely true. So, does the GC then see these two lines differently?
No. I don't think so. It's going to show up in the same line.
Unless you define T as X.
Right, unless. That's a saying, unless we do something else.
Different GC.
So right now, GC is going to read them completely different until he writes another line saying X equals T, capital T. It's going to read them completely different.
Okay, what do the rest of you think? Does it read them different or the same?
Okay, I see where you guys are going, but I still don't know what's going to happen.
First of all, is this going to graph something?
I guess not. Maybe.
So,
Oh, no. You have to have it set equal to Y.
okay. All right, so everything that Karen said was true. X is reserved in GC to be, the x-axis. And capital T is called a free parameter, a free variable. You can just introduce it and use it at your leisure. Except when you're defining functions. When you define functions, you can put anything in there as the dummy variable. So as soon as I put in this x in here as the dummy variable, in that command line, x lost its meaning as the x-axis, and it just became a dummy variable. So that being said, these two lines are exactly the same. When you define a function, this is the one exception to the reserved letters, the reserved variables. When you define a function, you could put even things that are, have other meaning, like x, y, t, z. All those things have special meanings in GC. But if you define a function with one of them as the independent variable, now it just becomes like any other symbol. So in that second line, x is just like the symbol capital T. It's called a dummy variable for the independent variable of this function. So I want to make sure. So if you want to define a function, you can use x and as the independent variable, and GC won't think that you're asking it to graph something. Okay. So how do we graph? How do we graph something? Y equals, right? So y equals a. Okay, so now the graph button comes up. I got the choice to hit the blue graph button down there. What's it going to do? What's it going to graph? What will you see? The curve, that function, the curve. What do you think? It'll graph a line. You changing your mind? She's changing her mind. Will it graph a line or a curve? What kind of line? All lines are straight? Horizontal line. Okay, at what? Does the way GC read this T, is it the same or different than the way it reads this T? Hold on a second. is the way that GC reads this T the same or different as the way it reads this one? Same or different?
Same then. Same, because it's going to graph it as a line. Because if it was to graph it as t is equal to x, then it would actually be a curve. But it's graphing it as this one.
Okay, but what line? I mean, so why are you guys saying a horizontal line? Where's that going to come from? Sienna, what do you think? Do you think it's going to graph a line? Okay, so what line is it going to graph? Okay, that's what I said, but horizontal line, where? There's lots of horizontal lines, right?
Well, I think because she said 11.71, that's if it was like starting at if the t was 0.
It was 0, okay.
So that would be, or she's thinking where it would start, or where we plot it.
So horizontal line at 11.71.
Yeah.
Autumn, what do you think?
I'm very confused.
Where did I lose you?
Huh?
Where did we lose you?
I don't know. I just, because this was the example we did last night, and so I never got a line last night. So
Right, okay.
I got stuck last night trying to do this homework too. Like, so bad.
Don't wait till the night before, first of all. And then email the questions if you got questions. You can email them.
No, I got a curve, but I never got a line. So that's why I don't know what you guys are saying.
Okay, so you think it should be a curve? I just went with the loudest voices in the room. So you think it should be a curve?
Line.
Really?
We did it with the homework, we did y equals a of x.
Okay.
So doing the y equals a of t is going to give us a horizontal line, but if we were to change that to x.
But be specific. Tell me about why will it give you a horizontal line, and what horizontal line will it give you? Why do you think it will? Leo. Okay, so that you're saying are both these t's 1 or just one of them equal to 1? So here this t means 1? No, it's a dummy variable defining the function, right? When you define a function, whatever symbol you choose is just specifying the independent variable of the function. So it does not take on 1 here. Do you see that? Now what about here? Now it's going to take on 1. It's now we're calling on the function. We're activating the function, and we're putting something in there. And what are we putting in? Whatever the value of t is, and since we haven't defined it, it's 1. So what it's going to define, what's it's going to graph is, so you were trying to say something?
It's going to graph the function a of t equals 1, basically.
A of 1, right? It's going to graph a of 1. So whatever we get when you plug 1 into this, it's going to graph a constant horizontal function. 13 point something? Yeah, there it is. Okay, so I want to make sure this makes sense, because this is, not only is it understanding GC, but it's really understanding functions. Really about understanding functions. So this line, capital T, doesn't take on any particular value. It's just taking the place of the independent variable. But now we're calling on the function. We're saying, all right, we want a value of the function, a of, in this case, 1, because we haven't said t is anything yet. So if I come down here and say t equals 0, now when I graph, will I get the same line or a different line or a curve or what?
Still a horizontal line, but it's going to be at 11.71.
She wants a horizontal line at 11.71 now. Yeah. Right. So it'll be a little bit lower, right? Down at 11.71. Okay. Does this make sense so far? This is really important. Okay, so now what if I do this? So if we want to graph the curve, we need y equals a of x, right? What about this? Is this going to graph the curve? It's going to graph nothing. what's happening here. So now I have a of x equals this expression with capital T's in it, and then I'm gonna graph y equals a of x. What will happen now? Why? Can you explain why?
Because you've never defined t as anything else.
Okay.
T is still 1.
Okay.
And a of x will graph, but since you have a constant in the a of x line where you defined it, then you'll just get a constant.
So now how? Yeah. So she's really what's happening here. So now we're defining a of x. X is the independent variable, equaling to this, which essentially what will happen there.
It doesn't have any independent variables in it because
There's no x's in it. So
Up to one constant in there.
right. So this is we've defined the function a as a constant function. Do you see that? It's going to put t equals 1. Now here it's going to make t equals 1, and it's going to give us that number 13 or something like that. So the function a of x is now just that constant number of 13 whatever. Does it make sense? And now I'm just going to graph that constant, so I'm going to get the same thing. What about this? What do you think is going to happen here? Same line. Same line. Is it going to be produced the same way? So you think we're going to get the same line? Will it be produced the same way or not?
Well, x can be anything. So by taking the function of another value, let's say pi in this case, it's still treating the entire thing as the same because nothing else changed, right?
So the red line and the blue line, the same or different? And what is there any? So when you say Brandon, when you say the same, what can you be more specific? What do you mean?
It was the same because you're not, because in a of pi, you're not like, since you haven't defined x as anything in the equation, it's still going to be like, because technically a of x is a of x equals like 13. So whatever x you put into it is still going to be like 13 whatever.
Okay.
And then it's now that you put pi in it, it's still going to be 13 whatever. Because you haven't defined any x in it, so there's no place to put pi in.
Okay. Other thoughts? With this? So do we all agree? Go ahead.
So since x is not an equation, or it's not in a function a of x, pi doesn't do anything to change it, even though it's being defined as x, because x itself is not in the function, right?
So this is now, by saying y equals a of x, we're saying graph this function a of x.
Okay.
Take different values of x and get the corresponding y values and then graph all those points. That's what this is saying. Do you see that? So this is saying graph a function a of x, where now this, what is this doing? What is a of pi?
Is it giving a specific point of value?
Right, that's one value. It's the same value, but it's just one value. And then it's going to say, for all x values, just make the y value that. So there's a subtle difference. We're going to get the same graph. So if I graph it, we'll get what? Purple plus, or blue plus red is purple, or indigo. Okay, so it's the same graph, but do you see that there's a subtle difference between what we're telling GC to do? Here we're telling it to graph for different x's, the corresponding y. Here we're saying just graph all points with a y coordinate that has this. But because that function was the constant function at this value, they end up being the same display.
Okay.
So there's a subtle difference. Okay. So all right, enough of this. We want to actually graph the curve, right? That's what we wanted. So how do I graph the curve? Should I change this first one here? And how do I need to change this? Do a of t. and then how am I going to graph the actual curve? Sophia, how am I going to graph the curve?
You have to do y equals, and then how, couldn't you just change, hold on, let me think about this. It's not as simple as just changing the t's to x, is it?
You want me to change the first line? Is that what you're saying? Do I need to change the first line? So I'm trying to figure out how I want to graph this function, truly all the different correspondence points of temperature and attendance. That's what I want to graph. How would I do that? Jessica, you know? Like this.
Well, get out the delete. So capital T equals X, and then a new command line, you put Y equals.
Yeah, so this, you don't need to do this.
You don't?
No, because we use capital T as a dummy variable, right? So it's just in this line, it's denoting the independent variable. I could have used any symbol I wanted to.
Then just Y equals the capital A with the control 9 capital T.
Okay, so that'll graph the curve.
Think so?
Kelly, why not?
Well, it'll graph the line because we were just talking about it, so should it be x?
So why will it graph? Why won't it graph the curve?
Because t is right now 1.
'Cause that in this line, that T is 1.
Yes.
In the function definition, it's where it's different.
It's a dummy variable.
Dummy variable, meaning it's taking up to say this is going to be the independent variable. But any other kind of graphing or computational line, T is going to mean 1. So we need,
I did x.
we're going to need X, and then we wanted just part of it, right? So from
0, x to 110.
So does that do it? Okay, got it. All right. So what is this line saying? It's saying take different values of X and get the corresponding values of A using that function, and then plot every point, X, Y, X, Y. So that's what it's doing. It's showing us all those points, correspondence points of this input and output, or independent variable and dependent variable. And now we're going to show them as all the different ordered pairs. And so that's why we get the curve now. Okay. Any questions on that? So this is a really important discussion to solidify our understanding of what function notation is and how functions work. Okay. So then we wanted to get this horizontal line to represent a change of 10 degrees, right? A change of 10 degrees. So how did we do that? I want to get a horizontal line. So first of all, point. So how do I get the roving point? I want the point that highlights some certain point on the curve. Remember how to do that? How do I do a point in general if I want to graph a single point? How do I do that? Control 2. All these basic things that you learned, you have to retain. Okay, you definitely got to retain all this stuff. Because when it gets hard, you don't want to be like having to look up all these basic things about functions and points. Okay, and so how do I do a roving point then? I want to be able to control which point on the curve it's highlighting. What's that? Yeah, so N, as soon as you type N, we get the slider down here at the bottom of the screen. And so then we want the Y. That'll be our X coordinate. We get to control the X coordinate of the highlighted point. And then what's the corresponding Y coordinate? A of n. Make it black. Okay, and then we can change. You click on the n, you can change. So we want to go to like 0 to 120. And how many steps? Like 22 to make it by 5s. Is that right? Something's wrong there. 110. Thanks. There we go. Okay, so now the n is only every 5 by doing it that way. Okay, and then I wanted, for the given highlighted point, I wanted to show a change of temperature of 10 degrees. How did we do that? Jesus, I'm going to show a horizontal segment that's depicting a change of temperature of 10 degrees. Good, good. Right, a horizontal segment has all the same y value. And so what y value will that be? Well, it's a of n. Okay. Be for all x values, good, right? And so we want just which x values? So now, like you said, when you do y equals a of n, you get all points that have that y value. So now what do we need? We just want from here to here. So is that a matter of y values or x values? Okay, so starting from what lowest x value to what highest x value? What's the lowest x value that we want? Is a of n an x value or a y value? Yeah, it's a y value. So we want the lowest x value is going to be for that line segment. N, okay, until n plus 10. Okay, got it. All right, and then, so we want the corresponding change, so that shows the change of 10 degrees, and then we want to show the corresponding change of temperature that corresponds to that change in 10. Yes? Without looking at what you wrote before?
I'm not looking at what I wrote.
Okay, good. So now I want to show
Going up.
this vertical segment that shows, what does that show? When the temperature increased by 10, we got a corresponding increase in expected attendance.
Right, so we're looking for a vertical line segment. That's going to be x equals.
Good. X equals?
And now it's probably going to be
X equals n plus 10. Good.
and we'll define it from
A of n.
smaller than or equal to y. Smaller than a of n plus 10.
What do you think? You sound a little unsure. So let's look at it and talk it out here. It helps to see the graph. So what do you think about x equals n plus 10? Is that right?
Yes.
Yeah, that's right. Okay, so now you want y to vary from, is the lowest y a of n? And is the highest y a of n plus 10? This is x of n, This is when x equals n plus 10, and then you want the function value at n plus 10. Yeah, good. Helps to see the picture. All right. Any questions on that? All right, and then the last part there was, why does this is looking good, right? We're doing great, and then boom, here it doesn't work anymore. So why doesn't it work? Why doesn't it work? So we've got this statement here. When we get over the top of the hump, why does the vertical line that we so accurately made disappear over here? Who was first? We'll go with Kylie.
It's because I think the packet said it was like 73 where the line stops working when n is greater than or equal to 73.
Okay.
At that point, as the temperature heats up, the expected attendance decreases.
Decreases, okay.
So the way we have it written right now, it's saying like the expected attendance is going to continue to increase by having that a of n plus 10 as the largest value you can have.
Okay.
So you have to switch that in order to get a line that goes down since the graph is decreasing.
Okay, so you want to switch them. So what does this line say? What is this? So this says what? That y is greater than, first of all, it says y is greater than a of n, and also y is less than a of n plus 10. So I'm just going to split that apart into two lines. All right. So what am I going to see when I turn that on? I got y is greater than a of n. So I want you to talk for a moment. Talk for a minute. When I turn that on, what's going to happen in the graph? What do you think is going to happen when I turn on y is greater than a of n? Go talk about it. See what's going to go. What do you think is going to happen when I turn on y is greater than a of n?
Yeah, I think everything's gonna be highlighted. Above the highest A and value. Or above the number one? Yeah.
But also highlight everything.
Well, that's why
You guys in agreement? So try to get an agreement at your table. Try to get a consensus at your table. You all agree what it's going to show. What's that going to show? When I turn on, y is greater than a of n.
still behind the second one. The second one, the line smaller than A of n. Plus 10 won't show up unless we're on the left side of that separation.
Oh,
So
yeah. Don't be on your computer. Don't do this. Don't do it. So it's about predicting.
Okay, so if we think about like
Did you do it?
y equals
Don't do it. Don't type. Don't type or look at your computer.
of n plus 10, right?
Do you have all the tabs packs?
Yeah, so y is less than that is just every single value below that line. So it'll highlight everything below a of n plus 10, regardless of which side of 73 it is.
Okay. Do we have consensus at this table? You guys consensus at that table? Are you still arguing, or you have consensus?
We're arguing.
Still arguing. What about you guys? Agreed? What about you guys? You guys are agreed. Okay. Take another 30 seconds. Make sure. Okay, what do you guys think? So when you do you mean like a kind of like a vertical strip like this?
No, like everything above that line.
Everything above that.
All the x values
Okay.
above it. Yeah.
What do you guys? So what do you guys think? What do you guys think? Shaped like just above the little segment or everywhere? So just in this like strip here? Everywhere. Everywhere. What do you guys think? So they're in agreement up here in the front.
You said it was going to be like
Everything
everything above the line A of n.
above the line A of n, which is what kind of thing? What that's called? Is it a line? But visually. Yeah, region. Is that what you guys are saying too? Is that what you're thinking? Okay. Then what about this?
Can you play n though? I want to see if the region changes.
Oh, if I change n, will the region change?
Yes. That's what I thought was gonna happen.
Okay. What about now the second one? Y is less than a of n plus 10.
I knew there was gonna be some overlap.
Overlap. There will be overlap between the two. You guys any different? There's going to be overlap?
If it's less than
Here. So here. So we're specifically talking about on the when it decreases here, greater than 73 degrees. Yep. Okay. She wants below a certain value with a gap in between the two regions. Brandon's not nodding. What do you guys think?
I agree for that specific point, that's how it would look, but if it moves, there will end up being some overlap.
Move to where?
Like if it were to move to n is less than 73,
Okay.
there would be overlap.
All right, so over here, she's saying over here there'd be overlap, but on where I have it positioned now, there will be a gap between it. Leo, what are you thinking? You agree with that? Okay. Okay, so we get over here when it's decreasing, and this is saying all y values that are both greater than a sub n and also less than a sub n of 10, n plus 10. So what y values are those?
None after 73.
After 73. We're talking about after 73. Yeah, we're talking about after 73. What y values are both greater than a sub n and less than a, not a sub, a of n and less than a of n plus 10? No, okay. We're only talking about the situation where t is greater than 73, okay? So you don't have to qualify that anymore. So we're just talking about when the graph is decreasing. That's all we're talking about, okay? So when temperature is greater than 73 and expected attendance is going down, what is all y values greater than a of n and less than a of n plus 10? There are none, right? I think you guys said that too. There are none. And so because there are none, this graph's nothing, right? Because there's no points like that. But like Kylie was saying, now over here, we see the overlap, right? So there is. It's going to graph this line only for those points where there's overlap. So the remedy then is, how do we take care of this? Not split it up. You mean split up the vertical segment? So how do we remedy this now? So we want to write a new line. Yeah, Britt.
x equals n plus 10.
Okay.
Comma.
Uh-huh.
A n plus 10.
Okay.
Less than an.
Right, because when it's decreasing, a of n plus 10 is less than a n, and And then this gets the order right. So then one last question. The last question is, this is something to think about. We're not going to answer it now. Is there a way to write, to get it to work, to show that vertical line for all values of n with one command line? With one command line. So is there some kind of mathematical tool that we could use so that we could just write one command line and it would always show the correct vertical line? So just something to think about. Okay, any questions on the assignment? Okay, so let's do some review. We're going to have our first assessment Thursday. It's going to be on this kind of stuff. So using GC to graph points and functions and other sets of points like lines and curves. So that'll be our first assessment. So let's practice some more here. So if you open up a GC file. Okay, so you're going to reproduce this to an extent. So you're not going to have a view slider for a view like I have there, so don't worry about that. You don't have to, so what I've done here is on a Mac, okay, so first of all, a really nice feature of GC is that you can have text lines. That's what I've done with fixed points. So if you do Command T, or I think it's Control T on a PC, then you get to just have free lines where you can just write text. And so this is really helpful for especially when your files get longer and more complicated to organize your files and put headers and give yourself information about the lines that are below. So, and when you do that, when you type text on a Mac, not on a PC, you can highlight and then you can drag it on there, and then you can grab it again and move it around. And then to take it off, you just grab it off the screen, and you'll see a little cloud appear or an X, and then you hear that? Isn't that cool? Let's do it again, right? Listen. And then a little cloud. All right, so unfortunately that doesn't work for a PC, but I'm going to show you some other ways later to get other kinds of visual images on your graphs in PC, okay? So that's how I made put these larger numbers on. I highlighted and dragged them one at a time. You don't have to do that, okay? So you don't have to do this. You don't have to make a slider here for view. But the first thing you do have to do is plot these 3 points. This is your first task. Plot the 3 points that I have plotted there. And like I said, all this stuff that you did for the TAPS homework assignment we just went over, this is all stuff you have to retain. Okay, you have to retain this stuff when things get hard, right? Some of these, in a month or month and a half, these projects are going to get hard, and you have to have the cumulative knowledge that we've learned up till then to succeed. Okay. So let's see. Everyone got. And then did you figure out the text? Were you able to? This one good. Remember how to plot points. Next task. I want you to maybe I want you to make your graph look just like this. Make your graph look just like this. Oh, so now I want you to do this 2 ways. So 2 ways, with a function and without a function. So using a function and without using a function. So both ways are important. You should be able to do this both ways. Okay, roving point. Next task. Roving point. And then make it so that it only roves on the part of the curve you displayed, which mine doesn't. Now the next thing is, if you go to graph, you can turn off the axes. When I turn off my axes, you'll notice there's something else there. So again, to change the to change your range of n, you can just click on the n. So we want to go from what to what? 0.5 to 10. Okay, now if you notice on my graph, there's something else. Okay, so first of all, before we talk about you reproducing it, what is it? What might its purpose be? So I've got a blue segment and a red segment. Yeah, Jessica. Right, exactly. So it's showing, it's a visual way of showing what the current value of the x and y of our movable or our roving points, right? So right now it's showing that x is around 2 and y is around 1.4. Okay, I want to show you how you can do these grid lines. So, for instance, the vertical grid lines, you can do them all in one command line. Because you've got a repeating pattern here, I'm going to show you how you can do this. This is more of a GC kind of thing here, but so say I'll do them in black now instead of gray. Okay, so what all those vertical lines, what's be the same about all those vertical lines in terms of the structure of how you would define those? All those vertical lines would be what? X equals, all right? So we can say x equals, we can pick a free variable, say x equals b, okay? Say x equals b, and then I want to tell GC to make b be a set of values rather than a single value. So I'm going to say comma, b, and then is a member of. So if you go control equals on Mac, I don't know what it is on PC. It's not control equals.
For which one?
To get the is a member of. Anyone?
Oh, it's
Control Shift E. Control Shift E on a PC. Thank you very much.
PC likes control shift.
Control, it does. Okay. And so then we want the curly braces. So you're going to go Shift, bracket, and it gives you the curly braces. All you need is the left one, and they both come up. Are we good still? And then we want to tell it which b values we want. So I'm going to start at, -10. And then I want to go by what? What increment do I want to go by?
5.
Well, actually I have them by ones. So I'm going to do them every one. So the next one I want is -9. And then comma. And then you're going to do control. So you just do the first two to establish the interval. And then do comma. And then you're going to do control semicolon, gives you the ellipses. Another comma. And then where you want to end. So I want to end at +10. Everyone able to do it, PC and Mac. And so then I'll make them purple so we can make sure we see it, or blue. And then that should graph. So what's nice is to do it gray, okay? So it's nice if you make them gray because it's just a grid to be the backdrop. So that's what I have there. So I have them in gray. So that just graphed, 21 vertical lines in one, because they all had the same x equals something. So that one line graphed all 21 vertical lines. So x equals b for all these b values, -10, -9, and so on to 10. And everyone figured that out? Everyone able to do that? So in that technique may come in useful when you're actually doing not just putting grid lines up, but when you're doing some more sophisticated mathematical graphing. Okay, and so that's like I made an animation of a wheel turning, and so then I did the spokes this way. So I graphed all the spokes of the wheel with one command line like that, and that makes your file a lot more clean and concise to do it that way. Okay, any other questions about this exercise? Getting all those elements to show up correctly? Yes, so that was what I was talking about the text. I dragged and dropped the numbers. So yeah, I used this text line and I wrote all the numbers down and I dragged and dropped them. But you can actually do that a lot better and faster with a table, but I just haven't used the table much. There's a table command in GC, and you could do that, and I need to learn that and be more proficient at that. But
I was gonna ask you how you got rid of the blue lines, but did you just put or are they there and I can't really see them?
I made them gray. So this one that I just wrote.
No, but I put draw graph paper and it went away.
Oh, so that's also in the graph menu. Say draw graph paper. Just take them away. So you can turn that light blue graph paper on and off also, just like you turn the axes on and off. Does that answer it? Okay. Okay. So if you look in syllabus, if you want some more practice, there's actually if you look in syllabus on Blackboard, I put I didn't know if we were going to have time for it, but we aren't. That is a GC file that has text lines in between. So it has text lines giving you instructions of what to do, but then it also has the command lines already ready for you. So you just do in the command lines what's telling you in the instructions. So that's a harder activity related to what we've been doing, and it's good practice for the quiz. So I won't be collecting anything with that. We could answer a few questions if you want at the beginning of class or in office hours, but that would be more good practice for getting ready for the assessment on
When is this quiz?
Thursday.